Awesome. First off, let's give Levi and the team a hand for everything that they've been doing. Awesome. Well, Bryan came in yesterday, and we found out he had a little bit of travel issues, and his luggage got lost in Denver. And so you're looking at a man now outfitted in Walmart apparel, and it looks amazing. And he didn't have to use any AI to come up with the color palettes or generate his outfit today. So, Bryan, the first thing I want to really just impose on the people here is just your deep knowledge and experience in AI. Could you give a little history and background into when you started to get into AI and what that looked like for you?
Yeah, for sure. Thanks for supporting the outfit, by the way. I really started on the AI journey in about 2013. I came out of a background in philosophy of language. I was really interested in meaning and trying to figure out what the heck it is and what it is when we do it, which gets translated into language for the most part in the academic world. And at some point, I felt like that was getting a little bit dry, or there was a kind of a dead end with the armchair philosophy approach. So since I'd been doing some computer science on the side for fun, I was doing systems like compilers and operating systems. I walked over to the computer science department and started seeing if we could use computers to study language instead. So 2013, I met my current co-founder. Actually, his name's Richard. He was in his PhD at the time, and he was at the very forefront of deep learning for natural language processing, and we pretty much hit it off right away.
That's awesome, man. And for those of you here, he has a master's in computer science with an AI emphasis, and then you've got a bachelor's in philosophy from Stanford University. So when Bryan and I were talking, I thought it was really intriguing that, AI is a big buzzword now, but he was getting into AI in 2013 when not a whole lot of people in our industry were really focused on that. And you said you started in deep learning. Could you give us a little history into the natural language processing work that you guys did and some of the new ideas that came from that and your belief behind that?
Yeah, that was a very interesting time for AI because there were a couple transitions happening. One was machine learning to deep learning, which was not accepted. All this talk of neural networks, doing deep learning, that was almost taboo, and it was kind of hard to publish in certain areas. So my co-founder, Richard, that was his big thing for his dissertation. It was deep learning for natural language processing. And me coming from the philosophical angle, when I saw some of that work, it looked like the best way to test some of the philosophical hypotheses that I thought were interesting as well. An example being this idea that like the meaning of a word is somehow reasonably described by the context it keeps, the words around it. It's like having your closest 5 friends somehow determine who you are. If you look at the words that appear around a word and try to predict that word from that context, then you can get really good at generating something that looks like meaning. We can just leave it at that there. But this whole transition from trying to describe the features that are relevant for a word or a sentence or an image or an object, to letting the algorithms decide, that was the machine learning to deep learning switch, was the first big thing. So we started working on that in 2013, and then some of the themes that came out of it were increased context. So my first published work later on was this idea of not just having a single word representation, not having like a vector for a word, and having the algorithm set that, but having a model, like a whole neural network run on a piece of text. and share that context.
Yeah, could you give a little bit more information behind the transition from machine learning to deep learning? Because I found that fascinating because it's not really talked about a lot. Just the fighting that was happening within AI science at the time. You know, you've got directors of Apple, you've got big name people that are saying, no, this is wrong, as you're working at Salesforce in the AI science department and all those types of things, and just how you were convinced that, you know, the natural language processing was the route to go for deep learning. Could you talk a little bit about how machine learning started and how, you know, you would define attributes and then how it went to where we are today?
Yeah, for sure. So maybe we could, you know, you can imagine we had like a picture of this cup, and you wanted to identify whether this was a cup of water. So in machine learning, or the kind of feature-based learning that we were arguing against back then, the idea would be you take that image and you try to describe all the attributes or features of that thing that an algorithm should take into consideration when it's deciding whether it's a cup or not, or a cup of water or not. So maybe, you know, is the kind of transparency a certain way? Is it maybe certain kinds of colors? Is it basic size and shape? And you could try to write down numbers for all these things, like a 1 and 0 for all the Boolean statements, and then maybe even some like real numbers or floating point numbers for like color, stuff like that. Or if you're doing a hat, right, then you could try to do something about the shape, maybe the spatial coordinates. You could try to write down all these things that could be important, and then let the machine learning algorithm decide which ones are important and how much. That's basically machine learning. So you get a list of features that you've defined, and you let the algorithm decide. The move to deep learning was, I'm not going to decide what those features are. I'm just going to give the machine the option to, instead of me writing down 300 or 1,000 features, it can decide what to do. It can have 300 or 1,000 numbers, and it can set them however they want, as long as it gets really, really good at predicting whether that's a cup of water. And why this was so powerful from our perspective, conceptually, when you're working with something like language, if you want to take a word like knowledge, I mean, my God, like what are the list of features you would write down to describe knowledge? You could try, like, and people did try, and we did for a long time. Or you could say, maybe instead of trying to write down a list of features, just try to predict the words around it based on you know, data that we get from all over the web. And then the deep learning algorithm can set those numbers however they want. And what ends up happening is, like, one word appears next to another word, and so when you're looking at those two lists of numbers, you want them to be kind of similar. Because if the list of numbers are similar, then those vectors, we'd call them, like those lists of numbers, are somehow representing that these words are used in the same context. They kind of mean the same thing. So something like knowledge and belief might have very similar lists of numbers, whereas maybe knowledge and you know, clipboard, very different lists of numbers, because they're almost never used in the same sentences in the same context. So it's really good for when we don't know how to describe like what we're trying to do. Really good for perception tasks, really good for language. And these days, there's a little bit of a trade-off because sometimes we do know what we want to do, so you mix them, but that approach proved pretty powerful. And then my next step was to say, instead of just doing that with words, we should just do that with everything. And we should just do that with one model for everything, be it language, vision, like images, video, audio, writing software, you know, having conversations. That should just be one single model. And we should think about this possibility, at least, that you could just have the algorithms decide what all of these things mean.
So
in some way.
What did that process look like? Was there like an aha moment when you and Richard started being like, this is working? All these people are saying this is not the route, but you guys are figuring it out. You've been cited thousands of times for your work on AI research for natural language processing. Like, what was the aha moment? What was that transition from you guys are all wrong, instead of them telling you you're wrong? It was like the script was flipping. What was that moment like, and what were the things that were happening in your research that made that true?
Yeah. So in 2018, so I guess 5 years later, we had a paper that we finally built a model that, at least in theory, could do all of these things. And the way it did it was by just taking in text and then outputting whatever you wanted, and it could generate that answer. So instead of building, a piece of software or like a model for a specific task, like predicting whether a sentence is positive or negative, or answering questions from a Wikipedia article, instead of thinking of those as different tasks, it was, okay, we have one model that can do all of these things. Now, we got that model to do just as well on all the things as if you had them in separate models. And that was the first aha moment for us. We were like, well, we believed this idea should be possible. But prior to that, every time you mixed these tasks into one model, you would get worse performance on all the tasks most of the time. And people would have very justifiable reasons for this. So we'd go talk to Google, we'd go talk at Apple, we'd present, and it made a lot of sense because you have a fixed amount of compute that you can dedicate to learning each task. If you just have more compute to learn each one, then you're going to do better. That was roughly the argument. And it turned out that to some extent you just needed more data and more compute, and then you would start seeing these nice properties where tasks started helping each other more. And I don't know if people have heard about the idea that if you're training, for example, like a language model, so a model that's predicting words or the things that are backing a lot of ChatGPT, if you train it on code, then it helps it in a lot of logical reasoning tasks in English. Like, what? Why does that happen? Well, on some level, there's some connection there for pattern recognition, that there's something logical about code, maybe, at least some of the code we write. Like, there's something good about reasoning in there. And then it helps you on like LSAT questions. It's like, whoa, that's kind of neat. But we didn't see that because we were in such a different regime of compute, data, and so on and so forth. And then if you went to Google Brain at the time and you said, I want to make a giant model with all the data in it. Like, no, what are you talking about? Like, the main principle of like engineering design to some extent is decomposing problems into smaller ones that we can understand and split up into teams and test them well. Like, what would we do if we had these giant systems? Also, it's expensive. What are you talking about? So even when we had that aha moment, there was still about 75% of the community, I think, especially on the engineering side, that was like, no way, that's a horrible idea. And so that paper that I describe as our aha moment never got published. Totally got slammed by the research community. Was like, some of the reviews are online. Don't look them up. It's just like, this is a terrible idea. This is never going to work. And then a year later, the GPT model started coming out, and OpenAI had cited this paper as like, hey, maybe we could do this. And they started pouring a lot of money into it, a lot of compute.
So I don't know if you guys caught that,
changed.
But OpenAI, right, is their entire thing is built off the work that you and Richard did, essentially, right? The paper, the hypotheses that you guys had, the research that you did.
Yeah, I mean, they've done good stuff too. But I think maybe the fair thing to say is, like, we were talking with them a lot at the time, and they were mostly focused on like robotics and game playing. If anyone remembers OpenAI from before, like, they were mostly like DeepMind. They were doing a lot of game playing, right? It was like beating Atari games and stuff like that, because the idea back then was that reinforcement learning, which was kind of a different branch, deep reinforcement learning, was going to be the path to AGI. But there was one researcher who I respect a lot, who we talked a decent amount around that time. His name's Alec Radford, one of the best. look him up for sure. Don't look at my reviews. Look at him. And he made GPT-2 after this paper came out. He had made GPT-1, but that was kind of a different thing. And then they did, we called it multitasking at the time for GPT-2, and then it just really started taking off.
Now, were you and Richard at Salesforce at the point that this paper and research was being done?
Yeah.
Okay, so that was 2018.
Yeah.
So now let's talk about you.com. So as you and Richard were gaining in your research knowledge and knowledge of AI, how did you.com, how did you guys come together and then start to co-found and decide to make that a venture?
Yeah, so we started seeing it work in a lot of applications over the following couple years, and we started training larger and larger language models. I've been working with some product teams inside Salesforce, the marketing teams, design teams, and we started building all these demos, and everybody started getting kind of excited, but there wasn't really enough like bandwidth at the time to pursue them within Salesforce. So that was kind of one reason. And the other was that Richard and I were always motivated by the idea of having as much positive impact as possible. So when we saw this inflection point coming where the tech might actually understand people better than ever before, whatever understanding means, the philosopher in me is like, let's not say understanding, but I'll grant it for now. If it can understand people better, then all of the ways that we interact with information are going to change. And one of the places we could start is in search, but we weren't so concerned with search per se, so much as that box where people start their journey. And we were thinking, okay, if you could really understand people, you don't need to just give them 10 blue links, which is the dominant paradigm for the last 20 years. You could start doing things for them, like actually doing things for them. So you could bring in the code into the search results. You could start bringing in writing assistants or art assistants and design assistants whenever it's relevant. And you could automate more and more of that stuff as well. So we wanted to get out in the wild, explore that. And I was also really curious about exploring like different business models that could come with that too. A lot of great things came out of Google and the kind of ad economy that and attention economy that supported it. But there's misinformation, disinformation was a big topic at the time as well. And we were thinking about how if you could really do the underlying work for people, maybe they'd be willing to pay for that instead of having it be a free service, because search is kind of free in some way. And then if you could do that, the underlying incentives might change around information and even like the creation of information. And from there, maybe you could like make the world a better place. So yeah.
So what year did you.com, was it founded, and where'd you get your first investment from? Give us just a quick snippet about that.
It was August 2020. Most of the world was shut down.
Crazy time.
And the part of the world I was in, California, was on fire. So we couldn't be inside or outside. So we left. Actually, Richard was like in a van, for the first year. We were all remote. We were doing that thing. But our first investment came from Mark Benioff. He was a big supporter of us. We worked with him at Salesforce. Richard was the chief scientist at Salesforce. So he gave us the domain name, you.com, which was cool. Thanks, Mark. Best thing we ever did. And that pretty much kicked off like our seed funding. We started hiring pretty quickly. And then a year later, we launched the first actual product version of you.com.
That's awesome. And at that point in time, you guys had built the largest language model at that time.
Yeah, at least the largest open source one. There were rumors that Google at the time had much larger language models, but they just couldn't share them with anybody or talk about them, which was kind of interesting. You mentioned before, what was going on with Google, Apple, all these big companies.
Yeah, because it seemed like you, OpenAI, on the very forefront of this, right? And a lot of the other bigger tech companies are even still lagging to this day. And we shared a little bit about some of the naysayers, the people that are still in control of these organizations that were saying, hey, this is the wrong route, and they were wrong, and they're still behind today as a result of those calls.
Yeah, it's kind of fascinating to look back. I mean, I guess you never really know. Like, we believed, and they had their beliefs as well. But it's shocking in some way that like a Siri or Google, like, they didn't do some of this stuff, unless you were there and you were in the room and you saw how like vehemently many of the leadership, like many of the leaders there, especially on the AI side, just didn't believe in deep learning, or even when deep learning was starting to work, they didn't believe in unified models. And even when unified models started to work, like, they didn't believe in scaling large language models. And then even if you got there, which Google actually got through all of those to some extent, at least in their research branch, then you hit innovators' dilemmas around like what you're going to do with the technology. Like, once everything is answered by a language model, what happens to your ad business if you're Google? So, and they struggled with that for a long. They still struggle with that.
So in some ways, it's counterintuitive. Like, hey, if we advance here, we're advancing out of these profit centers in our current business.
Yeah, 100%. And that was something we were counting on with Google as well, as we were kind of entering the search market. And we've moved more towards enterprisey B2B angle, although we still have u.com, and you can try a lot of stuff there. Like, the main meat of our tech is more on the Teams enterprise proprietary data side now. But at least at the start, this idea that Google would take a long time to ramp up because of their innovators dilemma was kind of essential for us to motivate ourselves that it was possible at all, but then also like when we were getting funding and things like that too.
Yeah. So in my mind, I feel like you were telling the world is not flat. And you've got people telling you, no, the world is flat. How does it feel now to know the world is round?
Good. Yeah, no, I feel like, but I don't know, the part of that's still true though, right? Like, I don't know that I don't know even know if I can really understand like all the implications of that. Like, if it's actually true, like if what we were saying is actually true, and like we could, like, we're just at the beginning, if that's still true. So, and you can see a lot of questions still getting raised in the community. Like, is there going to be ROI on all this AI stuff? Like, or there's some, maybe in some areas, but I think there's going to be waves of proving this hypothesis more and more. We probably need to figure out, power and compute and a bunch of other things along the way too. But in general, I think it's the right direction. And the pendulum has swung back and forth multiple times between like these large unified models that kind of provide breakthrough capabilities and show that new things can be done, and then splintering those out into small models that are really focused, maybe even better for building businesses to some extent. And I think there's like a healthy relationship there, actually.
That's awesome. So let's talk about ethics for a minute.
Okay.
Yeah. How do we, as a humanity, balance AI and humanity? Like, what makes humans humans? And then what's the line we're willing to draw to make AI AI? Or in your guys' research, are there things that you guys are seeing that is like, no, those lines are starting to blend in a way that could be dangerous for AI, or it could be dangerous for humanity?
Ooh. So, I guess a little anecdote from my first paper was that I was making all these neural networks and training all these vectors that I was describing before, all these word vectors and contextualized word vectors, and I was straight up like looking for meaning, right?
And really quick, I have no idea what word vectors are, so if you don't feel like you're not smart.
List of numbers. It's a list of numbers that describe like the word, instead of like how I was saying before, a list of numbers that maybe describes the cup, a list of numbers that describes a word. And
So it's like a fingerprint or a DNA.
Yeah.
To some.
Yeah. And then if lists of numbers have numbers that are closer to each other, then they're more similar to some extent. And you could say they kind of mean the same thing. And it turned out that I ran this one experiment where I was translating German to English or English to German, and I had accidentally set half the neural network to be completely random and not update at all. Just meant nothing to me as a human. It meant nothing. And then the rest of the neural network learned to do the task well anyways. So even though all the word vectors, all the things that in my mind was like, oh, these are like meaning for these words, were completely random, set to nonsense, the algorithm adjusted in other areas somehow to make it all work. And I tell that story because as someone who was looking for meaning, and for us, as maybe we go through a little bit of an existential crisis with AI and have to look for meaning, I was like, where is it? It's like not in there. It's like not in the machines. And so I don't know exactly where it is. I don't know what it means yet. That's still a philosophical question for me. It's definitely not in the machines. It's something that we do. And all the things that they're doing with these language models, even though it's fantastic and it can make you more productive and great, I think there's a way that it can be, I don't know, it can help us answer this question of like what is meaning and maybe what it means to be human, you know, as it continues to push further and further from chess to Go to writing our emails to, I was talking to Matt a little bit before around, you know, this idea. My original goal for AGI might sound a little insane, and I don't know that I want this to happen, but the idea was that it should be better than humans at everything, like literally everything. Like classifying cups, sure, but also like having a conversation, like being a good friend, maybe being like a romantic partner, like, on some level, the scientific goal for AGI, or whatever it is, whatever you want to call that, AI, should be better. It can learn everything better than we can. Faster than we can do it, it can do it better. If that's true, it's going to push us pretty hard.
Where does that leave humanity then? Like if AI is better than everything with us, do we turn into lower in the food chain?
I think that's a good goal for the scientific approach, but I'm not sure that we'll ever get there. I kind of see it if I back out a little bit from that and I say, okay, as like the scientist and engineer in me, I want to try to make that happen as much as possible. I'm going to hack everything and work every day to try to make it as good as possible on everything. I kind of have that thread in my head, and then I switch to the other thread where it's like, okay, now that it's really good at all this stuff, what's left? What's left, and like, how can we be really good at that? And what does it tell us about who we are and what we're doing and what's really valuable? Like, is what's really valuable for me even coding? I don't know. There could be a day when AI is better than all of us at coding. I don't know. I don't even know how far along that day could be. It could be years. It could be a decade. I'm not sure.
Sounds like you think it's under a decade, though.
I don't know. Better than me, under a decade. Better than some of you, never. But that's the idea, you know. Like I think it will push us to some extent to focus on the things that we're uniquely good at, and because in my mind I can't really describe what would be uniquely human or innately human, other than connecting with other humans, perhaps. It's a useful tool to like push us away from chess, away from that kind of intelligence, away from Go, away from maybe even generating images and maybe doing a lot of the things we do now, and then we can talk about like how we attach value to that, right? Like that could have a lot of economic implications, but I think that could be really fascinating to see if it really goes as far as it could go. It has a lot of like individual maybe identity questions for people.
Yeah, I think one of the things that I thought was really cool in our conversation was just how when tasks get removed from humanity's plate, it creates space for new innovation and new problems to solve, right? And when I think about you.com and I think about all these generative AI pieces and where we are today, it's a great starting point. Like the 0 to 1, it gives us options for what does the first draft of this paper need to be? What does the first draft of this function need to be? Or it gives us a lot of really good entry points, but it should never, at this point, you talked about how it shouldn't be, you just take the first thing that it spits out and say, print it, we're done. There's still this human gap that exists to where we've got to be informed by what this thing is putting out, and then we have to take it to the next step. How does you.com and the features that you guys are creating support developers, designers, researchers, business executives? Like walk us through here the tools that you've created to help humanity at this point, not take things away.
Yeah, no, I think that's the right focus. Because the way that I've always enjoyed using language models and such, even when they were a little bit smaller and not as good, was to just generate ideas or thoughts that I probably wouldn't have had, or if you think about them as capturing some average of what all of us have done and thought before, then whatever it spits out is the average or what has been done before. So if I ever want to do something interesting or creative, I should not do that. It can save me some time in not doing that and showing me what has been done before. So it catches you up from like 0 to 1 or maybe to 0 to a half or whatever it is really quickly. That's great. And then you can go further. It can just be inspiration for like more stuff. Maybe that's what we're really good at. Like humans are great at finding more work to do. And with you.com, our approach, especially over the last year or so, has been to think about it less as searching for answers, and more about like doing comprehensive research for you. So if you think about like a Google search, most people are like, put in some keywords, get a quick, concise answer, and then assume that it's true to the greatest extent possible. If you use a u.com research mode, we're optimizing for something different. We're optimizing not for necessarily conciseness, but comprehensiveness. So you'll get much longer answers, but they're also going to come with many queries that we wrote on your behalf and then did all those searches on your behalf. And then we brought all of those sources together and we cite those sources, and then we have citation models that check that what the language model says is actually implied by what the source says, and what the source says is implied the other way. So actually making sure that's all really, really accurate. And it might take 10 seconds or 5 seconds, but it's a very different kind of answer. And so it's my most used functionality of u.com proper on the just kind of out of the box side. If I meet with a customer or want to do some sort of investment or something like that, just save me a bunch of time by more or less doing 10, 15 searches for me, bring it all together, and don't make a decision for me. That's not what research mode does. It just goes and does all that stuff for you so that you can read it really quickly, and then you can make the decisions, or you can take the next steps.
I think what I like about that is it kind of removes bias, right? Mm-hmm. This implicit trust in something. You go to Google, it used to be like, okay, the first 3 links were like the most trusted links, so then that was it. And now you've got the little snippet above that sometimes, with hallucinations and stuff that exists in models and things, like it may not be right. Like I think one of the things that we were most recently saw at one of the Google answers, especially around sports, is like legacy of certain athletes, like winnings, right? And stuff like that. Like it was completely wrong. Like the PGA Tour had the wrong winners and stuff like that recently. But the research mode for you guys is like, it's not like, hey, here's the answer. It's here's the research that it did. Here's all the things that it went and read through, and it's giving you the information for you to then say, okay, I need to do a little bit more digging to find the exact answer. Is that essentially what you're saying?
Yeah, exactly. I would much rather have it say, these are the 3 sources that say these things, and they disagree in these ways and agree in these other ways, then this is the right answer. Just in research mode, at least.
Yeah. That's great. Yeah. So another thing that I find intriguing about the u.com product itself is just how many foundational models that you guys are pulling from that, and you give the user the choice of which one they want to have as the base model. Can you talk a little bit about that?
Yeah, so we're kind of a model agnostic platform. So all the foundation models come in, and then our tech makes them trustworthy. So it does this process of attaching citation models to them, understanding your intent, going back to kind of those early foundations there, like understanding what you want to do, and in some cases letting you can choose whatever model you want, or you can let us choose, and we can create like different kinds of prompts for you on the fly. So for us, it's this giant system that sits on top of the foundation models. We often call it like our trust layer, and we can do that with public data. But what we're also seeing more and more is interest, and this is where like we're currently focused on taking something like the research mode I was describing and applying it to a company's internal data, and maybe even mixing the two.
That's awesome. And so you guys just recently raised your Series B, 50 million. Congratulations. And one of the hardest times to raise capital. When did that officially close?
Spring, this year.
Spring.
Yeah.
Yep. Congrats. And so talk a little bit about what you're doing with that investment for people like us in the room. You know, you told me a little bit about third-party tools, allowing your guys' infrastructure, and what you guys are building to allow us to be able to build these things for businesses, for ourselves, for new products, things like that. Can you walk through what that looks like?
Yeah, so the whole thesis behind this most recent fundraise is that intent understanding that we build, that research-like technology we build, all the trust-based stuff, the citations, that can apply to questions for biotech firms or VC firms, financial institutions, banks. If they have 20 million PDFs, or if you have 5 PDFs, it doesn't really matter. You can put those in and start asking these really broad questions like, should I invest in this company? And instead of just getting that, that's not necessarily like helpful to get a yes or a no, quick Google-like answer. Instead, what we have started doing is building these automated workflows. So it'll.
And this is more the agentic side.
Yeah. So this is getting into the more of the agentic side where we'll have the AI.
Can you describe that just a minute so they understand what that is?
Yeah. So you basically have the AI decide what to do next. So if you type in a query like, should I invest in this company? Or, should I buy this software? Whatever it is. Then that query alone doesn't really imply all the things that you would need to do. If you were making that decision, you'd probably make a bunch of Google searches and maybe ask some people some things. And, you'd go look up the founders on LinkedIn and do a bunch of research. So what we do is have the language model decide to do those things, essentially write out a plan for you, and then it just starts doing it. It starts making calls to APIs. It starts going and crawling pages live. It starts going into the data that you've uploaded, whether it's CSVs or PDFs or whatever it is, and tying all that together to bring these like really comprehensive research reports, or maybe even generating other types of collateral, like slide decks, if you're trying to bring that to an investment committee, or writing other forms of code for you, maybe starting that web application for you. And so trying to get further and further into automating the workflows of like the core value prop.
So for an investment company, normally they'd spend a month doing due diligence before they would even give a term sheet, right? You guys are essentially building a way for this investment company to identify the company that they're wanting to invest in, potentially, and putting in some base information that they have, whether that's financial reports, PDFs, slide decks that they may have, and then you're asking it, should we invest in this? And then it's going out and doing all the due diligence and all this data, and then coming back with a research report on it.
Yeah, exactly. And slides, maybe images, plots already created for them based on like all the data analysis that the LLM might decide to do for that. So yeah, end to end.
Are you seeing anything in that on the developing side? Like, hey, I want to develop this application that does this for this type of a user. Here's some user persona information. Here's the attributes we want to track. Are you guys doing anything to where it's going out and developing an application?
So we haven't been as much. I think it's super interesting. We had a bit of a developer focus earlier on, But I think to some extent, much of where the technology is right now is really good at like being side by side with developers, like in an IDE or in their coding environment. And so we actually started focusing more on these cases where you have all this data and
like
you just
business
need
analyst
analysis done.
type
Exactly.
stuff. Okay.
Analysts, researchers, other kinds of similar knowledge work.
Got it. Cool. Well, any advice for anyone looking to raise money, do a startup, have a vision that everyone else is telling you is wrong?
Yeah, that's what you should do.
Yeah.
Yeah, but kind of seriously, like you should, like if you're interested in AI, if you want to get into that or whatever else it is, get into it, learn the basics, and then like look for areas where you have a strong sense that it should be different, and ideally, 90% of people disagree with you, because if that's true, I don't know, that's been my heuristic. It's like if 90% of people disagree, okay, I'm not entirely alone. There's some people I can collaborate with. There's some evidence I'm not crazy. But also if I don't do it, and like the small number of people that also believe if we don't do it, then maybe no one will do it. Like it might not happen. That's kind of a cool metric for impact. To be like, well, that's part of the reason why when we were leaving research, it made a lot of sense for us, because people started seeing that these language models were working and scaling was working and deep learning was working. So the thought was, my next 10 papers, like, do I need to do those? Probably not anymore. Probably someone will do those. So what do they not think should happen yet? And, when we started raising for you.com originally, we said, oh, we're going to start a search engine. We were like, what are you talking about? Like, Google. Dude, Google. Have you seen Google? I don't know. 4.5 years later, like, Google's still pretty dominant, but there are cracks. Like, it doesn't seem as crazy. And so maybe it's a little bit longer than the research journey, but I think there's like a similar trajectory there. And I get a lot of personal fulfillment out of that kind of impact.
So what's the impossible thing your mind is consumed with right now?
Automate all of work and imagine a post-work society. Yeah.
What does that look like?
I think that's a great question. I think we'll probably come up with more stuff that we call work, but I hope that it's just like everybody's more aligned with things that are like really fulfilling for them, and all the stuff that maybe they don't want to do, then we don't have to do that. So it won't really be post-work. It'll just be post the kind of work that is like a slog.
Do you think I'm just going to ask a question. Do you think all humanity will get the benefit of not having to work and slog? Or do you think it will push, by taking some of those things away, it will create more of a gap in society?
Yeah, that's a great question. I think it's going to depend a lot on each community, maybe country, whatever granularity you want to look at, like their value systems and how much they want to engage. So for example, we could imagine a world in which like a lot more data is collected and your economic value is tied to improving the AI almost implicitly, maybe just by like being alive and doing things, like interacting with things. If you really had finer grained data, maybe you could do that. Will people like that? Probably not. So I would say no, it probably won't be like uniformly distributed. Probably there will be pockets of communities that are like, yeah, let's just embrace this and see what we can get out of it, and then there will be pockets that aren't. So yeah.
Cool. Last question, then we're going to open up to question and answer. But you mentioned, you had this idea, and 90% of the people were saying it's impossible. What were some moments where you were up against a brick wall, or were you ever questioning yourself at any point in this? Describe what that process looked like when you were in the desert, so to speak, by yourself with this idea, you and Richard, trying to figure this out with very high-level prominent people telling you that's the wrong direction to go. Like, what did that learning curve look like? What was that emotional experience going through that process? Because I think that could be encouraging to other people in the room. I know for me, everyone has their own journey, especially if they're a founder or doing some different things where they're hitting ceilings, and there's this cyclical loop that you've got to go through to where you're raising your capacity for that next level to break through.
Yeah, I think that's a really great way to frame it. Most of the time, I guess, especially the first few years, it was just like, there's the obvious things that you look at if you like looked at the video of my life, where you're like, wow, you just spent 5 nights in a row in the office, like looking at plots. Like, what are you doing? You just tried to debug this GPU because CUDA, like NVIDIA hasn't implemented this CUDA kernel yet. Like, what's going on? And I think the way you framed it is great, though, because even though at the time, well, let's see. So at the time, the difficulty wasn't so much other people. I actually really thrived off of it when people said we were wrong, because my conviction was so strong in the idea. I just thought it was true. It was like, if this isn't true, then all of my beliefs are wrong, and I don't know. I have to re-examine everything. This has to be true. This is like the truest thing I ever felt. So I didn't have lack of conviction in the idea, probably very helpful. But then in those times when you just can't get the numbers to work, and you just can't get the neural network to do what you want, or you can't build it the right way, then I guess there's more of like a self-inflicted critic in there that's going after it, and you wonder why. But then when you push through, I feel like it often made me just think about the problem so much differently. And I think as I've gone on and done that like many times now, maybe on like a weekly basis, as my teams push me to keep getting better and better, I would say I just try to identify that like feeling more and more and ask like, okay, what's really going on here? I'm no longer going to doubt myself, because I've been through that process enough times, but I might need to shed some version of myself or some attachments I have to like how I do things, or how like the org works or the company works or the community or our customers. I need to like shed some expectations and biases there, and just go about it very, very differently. So now I use it as kind of an indicator that like, hey,
Something needs to evolve.
something needs to evolve. Start entering more of like an exploration phase.
Does it ever feel like a muscle where like, okay, you got to break the muscle down so that it can grow back stronger? And then every time you do that, you're able to lift more weight, right? You've got this even ingrained in the very fabric of humanity at the cellular level. Do you see that play out in your tenacity to achieve new heights of innovation in your field of study?
Yeah, I think that's a great analogy too. And then you could layer on everything else, right? Like there's the raw thing that you're doing, maybe that's like the muscles, and then there's, how you're improving on achieving like goals, if you're like planning your workouts and tracking them and monitoring your diet or whatever it is. So there's all these levels at which you can kind of see how you're getting better. And you do need, I don't know, I do feel like you then need increased stimulus to promote growth, right? So
you never got to a point where you were like, I can't do this anymore. That was never in your mind. It was further up and further in. Like we're gonna make this happen.
yeah, no, I think every time I achieved one of those aha moments or one of those milestones, I was like, damn, why'd that take so long? Like, man, like maybe if I would have been better or something, like maybe if I'd done a PhD instead of going straight into research, like I would have been faster at this or something like that. It just feels very achievable once it's achieved, I suppose. And so you're on to the next thing.
Yeah. Do you find like the next thing that you're on to is like you can achieve it faster? Like, is it like a habit stack type of a thing?
I think the next thing of the equivalent difficulty or complexity, but typically the next thing is increased difficulty and complexity. And so for me, there's usually like
that time horizon.
Yeah, it's the time horizon that stays roughly the same, but then what you can do and how you do it in that time changes.
It's awesome. Well, Bryan, thank you. Let's open it up into question and answer. And Levi, I don't know how you guys have done that, but I guess just create a line. Awesome.
Okay. So my question, I was curious about the internal training for AI that you do like within a company. And what I'm picturing in my head is you have, company A with their trained models, and then you have company B, and they have different data. They have different, just everything's completely different. What does that look like to like work with different companies? Like what would you suggest to different businesses in order to like maximize anything that's internally trained, if that makes sense?
Yeah, no, I think that makes a lot of sense. We had this at Salesforce too, like tenant-specific models where you couldn't share anything, and it actually made it somewhat hard to make the larger models better. So I think the idea is, so if you're the company, like if you're company A or you're company B, then I think the idea is you have to just bite the bullet a little bit and get as much data as you can, and then try to build your own muscle for developing those models. So like be rigorous with the evaluations, so on and so forth. But if you're like U.com and you work with company A and company B, you can never share data, but you can build more general solutions, I suppose. So that's like why, for example, we don't train foundation models from scratch. We might do some fine tuning, but we try to build like processes that are like another black box that just like takes in a model and then outputs something really good for that company. Building an index for them, building a vector database, whatever it is. We try to have this like suite of tools we can apply to their situation. And it really comes down to like making sure you understand the goal and doing that really well.
Okay.
I think something that's really exciting about that is you guys are creating these tools that we can all use to do that.
Yeah,
With
totally.
this next funding stage.
100%.
Hi. Going to try to make sure I word this question in a coherent manner. So we talk about AI and neural networks being able to be good at a wide range of tasks simultaneously instead of just being good at one task, like identifying a cup. It can also identify if a sentence is positive or negative, if it's a question, so on and so forth. What is the relationship between the amount of data that the AI gets trained on and the increase in competence for its ability to do those tasks? How does that grow, and what are the needs that we're looking at in terms of data to make something that can rival, say, the most competent people in a field?
Yeah. So far, so there are lots of papers on this too that I could send you. So far, I don't think we've seen like an upper bound to most things that are relatively complicated tasks like language. I think the problem that we're running into to some extent is that we're running out of language that is easily accessible. So I think like OpenAI and others are starting to face this problem. They're having to get like really clever about where they find data. Like they've used most of it. And maybe to like the last question too, right? But there's a lot of data inside companies that isn't just on the public web. And that could be, there's something we could do there. But so far there's like a scaling law that's like kind of exponential, kind of sigmoid probably at some point, that more data is more better in the models. And the more you can like find, then you're better off. Yeah.
So I kind of have like a two-parter, but so like making certain assumptions, like AI isn't yet capable of like novel thought. It's pretty much pulling most of its information from already generated content from humans. We've seen talk of like the whole dead internet theory, like much of AI today is just pulling from other AI content. And we also have certain like algorithmic incentive structures on a lot of different platforms to like incentivize the production of certain content or getting views or comments or interactions. And a lot of that stuff today is being done by bots or AI. So the first part of the question is, what should companies be doing to adjust their incentive structures to factor in AI? And then the second part is, how do AI models, I guess, avoid growing in their understanding from past AI models, or how do you avoid the dead internet, I guess, is the second question.
Yeah. So incentive structures. I think the incentive structures are going to be like more and more important. So I think that's like one of the most important questions that could be asked, because especially as we're maybe running out of data and everybody believes all of their data is like really valuable. But it all depends on like that goal that we're talking about, right? Whether it's the incentive for that company or it's this incentive structure we built for the internet, like comments and likes and whatever the bots are optimizing for. Like, let's just assume that AI is going to keep getting better and that bots will keep doing more things. Then it becomes even more important for us to set the goals right and get the incentive structures right than it is for us to do those things. So that's not like a complete answer, but I do feel like every company should be thinking about it, and they should also be trying to think about which data is actually valuable to them. I think there's a lot of companies that have like data that they just have and then they think it's all valuable, but I would love to see something like a data exchange start forming, where companies can like share some of that data internally, that you say like, this is the stuff that's really important for us, actually important, and like maybe I can sell the rest to this other company that it'd be really important to them. And instead of just operating through these external incentive structures, you could have more data passing and data sharing happen. And I think that'd be like a really interesting kind of coalition of companies that could evolve in different areas. Yeah.
I think what's cool about that is like, how do you align incentives to where the data sharing happens because both parties are getting incentivized to do so?
Yeah. And then the dark web or the dead web, I actually think it's like not super hard to like detect AI generated text. So like it was always pretty easy. And the underlying principle there has been that like a model is an average it's like a fancy average. And so it's really good at predicting the next word, but what often means is that it's good at predicting the most likely next word, which is rarely the word that humans will pick. Any particular human would pick. Because like I might pick one word, you would pick a very different word. The language model has to kind of choose between the two, and it often does. And so there's no humans that actually talk like that in most cases, even if it's hard to detect for us and like human eyes. Usually there are patterns statistically that are just odd compared to like a real human. So I don't know if that'll be like that much of a problem, but there's this other thread that suggests that as the algorithms get better, that it's okay. That as long as you're training on really, really high quality text, it doesn't matter if it comes from a human or an AI. Maybe that's true for images too.
So if I could clarify, the thing that I've seen is all these platforms have a certain consensus bias that AIs sort of piggyback off of to determine what answers are more acceptable. So they'll sort of look towards that consensus bias, like a Google search. The highest rankings are going to be sort of more preferable to pull from than the, page 500 or something. They're not going to look there. If more and more of those pages start becoming content from AI models, they're going to keep pulling from more AI model data based on those piggyback platforms. Is that sort of a different way of thinking about it, or is that pretty much what you're talking about?
I think for me, I think about that in terms of like it wouldn't bother me if the top 10 Google pages were AI generated, as long as the sources that generated that information was reliable and trustworthy. So I suppose I'm not super bummed if most of the stuff we interact with one day is AI generated, as long as where it comes from is transparent and you can track it down and like trace the sources. And in those moments, especially like over the next 5-10 years, as we maybe go through exactly that change, we all get to come along and say like, no, this is not a trustworthy link in that chain, or not. Kind of how we do like Wikipedia, for example, right? Like Wikipedia is not written by any one person. There's a lot of like negotiation, but the overall article is created by us. And I'm kind of okay with that in the AI case as well, as long as the grounding is good.
Thank you.
I read a really interesting article recently, and it has to do with, and it called, I don't remember the title or the author, but it had to do with something called the black box problem, and specifically how it affects computer scientists. The idea being, it's mostly about the order of which we ascertain whether something can be done versus its implications. And with computer science, it's particularly hard. Oftentimes, we're like, I think this code will work. And then we check to see if it'll work. But unlike hardware or things you manufacture, once it is known that the thing can be done, whether or not you decide to do it, someone else will decide. And you were talking earlier about that 90-10% split of people who think it can't versus who can be done. At that point, the box is closed. But the minute you found out it could be done, it's opened. As we move forward into kind of this unprecedented territory, how do we manage that order of trying to figure out the implications of the thing versus figuring out if the thing can be done? Because once we figure out it can be done, it will be done.
Yeah, and I'm assuming in there's kind of baked in the idea that maybe some things can be done, but like they shouldn't be done. Is that the worry?
Shouldn't be done, or that they'll have massive negative implications that require more than a couple meetings to figure out.
Yeah. It's a tough one. I think like when I was doing our large language models and open sourcing those, we talked a little bit about this as well. And there's been a lot of strategies proposed, and some of these are used, like delaying releases and making sure you get people together and spend a lot of time thinking through those implications. In general, I think it's really hard to do that. Like you're saying, it's hard to put things back in the box once they're out. So perhaps like the best thing we could do is just have as many of these conversations as possible. And you're right, it might not be like 2 or 3, but maybe like more and more people need to be talking about it, the greater the potential negative implications. From what I've seen, I actually think like the AI community did a reasonable job so far. Like ever since we started doing large language models, there were ethics committees and things like that. Did they always get their way? No. Like people didn't slow down. So maybe that's an issue. Maybe they didn't have like enough like control, if you think they should have slowed down so far. But I also would say that I think to some extent we're really bad at anticipating like what the consequences are going to be. So we kind of just have to get really good at mitigating a lot of that once we do figure it out. Like as many people as could have sat down 5 years ago and planned out like the potential negative implications of LLMs, most people were concerned about massive disinformation campaigns. I'm not sure that's been like the biggest problem, So we're really bad at predicting what those things are going to be, and so I don't know. It's really hard. I don't know how you have those conversations until you have like a better sense of what's going on.
Right. Thank you.
I mean, we've all watched Jurassic Park, though.
I
I said we've all watched Jurassic
Jurassic
Park.
Park.
So.
But they're doing that. There are people doing that, right?
Yep.
No, I didn't.
Yeah, like that's happening. Look it up.
Wow.
They're like, you say that, but now people are doing it. The
There's a guy
box has
did
been
that with,
opened.
sheep actually recently and gotten a lot of trouble for that.
Yeah.
Mountain goats.
Around
So my
dinosaurs.
question is about quantum computers. Do you think that they're on the verge of about to pop off and change our relationship with data and compute, or is it fundamentally a dead end? And either way, what are the implications for LLMs or the pursuit for GAI in general?
So yeah, I guess I'll preface with, I'm not a physicist. I'm a lowly computer scientist. And so from talking with physicists to some extent, like I feel like some of the companies out there that are working on it are making pretty good progress, but it feels like we're missing a couple, like this is obvious. Like we're obviously missing a couple big breakthroughs. Like we can't just keep making one qubit and then another qubit and then now we're at 100 qubits. Like wow, which is very impressive. Don't get me wrong. Like super hard, and I have no idea how it works. But it feels like we're missing those moments that we had, some of them on the AI side, where it was like, oh no, we should just be doing this differently. And like, yes, qubits are relevant. We knew that was gonna be true, but now there's like this level of abstraction we're working on. So I guess because we haven't seen those, I have to say, I don't think it's particularly close, but extremely hard to predict when those will happen, and I'm not qualified. So I do think very interesting combinations come up once you have AI advancing the way it is with all the data that we're ingesting and quantum computers, because like the neural networks are essentially exploring a bunch of possibilities as well, and then coming up with like a very simple yes, no on various questions. Yeah, I think there's gonna be really interesting combinations once you're like running AI inside quantum systems and things like that.
Yeah, real quick on that, because I mean, you were even talking about how some of the tests and experiments that you were doing, you were loading up an experiment that would cost $1 million, and it's like if you got that wrong, would quantum computing essentially take that risk down a little bit because you have?
Well, I guess I don't know, but I assume that quantum computers are actually more expensive right now.
I guess that's true.
But once we figure it out and we make those breakthroughs, then yeah, instead of us running, a bunch of experience, so when you're training a neural network, I often think about it as just like a search problem. You're like searching for the right numbers in those lists of numbers, like the right list of numbers in those vectors, to make the problem work and to be good at it. And so if you're searching for all those numbers, the more compute, the better. The more experiments you can run, it's better. The more data you have, the more it's guiding your process as well. So that's better. If you can do quantum computing, then you get it's just you can explore that possibility space like way more efficiently, which is cool.
My question's about like the trend of AI. There's tons of news on either side. It's happening immediately. There's major roadblocks on the way. What's your take on, are we heading towards stereotypical super AI? And if so, when?
I think we're we still have a lot to mine out of the current paradigm. I do think there's like a couple big things missing. Like we're starting to kind of get some sense of planning, but like very little on like objective setting. How we were talking in the earlier question too. Like it's really important for humans now to like set these incentive structures correctly. If a bot's just gonna go do everything and execute exactly what you say, almost like you're coding, then you better describe what you want really, really well. But like they're not very good at that. The AI is not very good at that. And it's not clear that we have like a good sense of even what to do there. It's not clear that we have access to the right kind of data for it. So I think we're missing some big things, but it's in the right direction. Yeah.
He did say earlier, though, that within the decade, we won't have jobs.
We'll have valuable social roles.
Terrifying. All right.
After these questions, we're going to start lunch. So sorry if you didn't get in line. Make sure to grab them afterwards.
Okay. Oh my gosh, I forgot my question now. Okay, so there's basically been like a giant like cultural shift from like when I was younger to like the fear of AI, like, ozone Skynet's going to take over, to now. And it's like, I've noticed, especially online, there's almost like a religious element to some of it. Like people are very hopeful, like, okay, I won't have to work. I can just like get like basic income. Like, I know that the reality is going to be some sort of middle ground. Like you guys are talking about it, like some people are going to suffer because they'll lose their jobs and they won't be able to pay. Like, what keeps you personally hopeful for that it's going to be a net benefit overall if we reach like a, where it can actually take our jobs?
Yeah, I guess the snarky answer from before was like we're really good at inventing new work to do. But I guess more seriously, I just think we're actually just we think we're creative and we think we're smart as a species. I actually think we're way more creative and way smarter than we think we are. It's just that most of us don't get to spend most of our time on those things, like maximizing for that. And so what keeps me hopeful and optimistic is that we have no idea what fraction of all the energy and like heat expenditure we're giving off by like running these brains, if we could focus on the stuff we're really, really special at. And maybe that's making meaning or whatever it is in some form. To me, that's a compelling idea. Not necessarily in like a religious way, I don't think it's the answer, but it's enough of a story for me to think, yeah, like if I spent all of the time that I spent only on the things that I was really, really, really good at and special at compared to other people, then generally like I'm doing my job better. In fact, I try to do that. I try to automate as many of the things as I can so I can do the stuff that I'm really, really valuable at. So if we unlocked that for everybody, like all the billions of people,
Plus with the extra new tools, like
that could be like a cool world to live in.
I like that. Good answer.
Thank you.
My question revolves around your kind of general implication that the march towards AGI is inevitable. You yourself said that your goal is to eliminate human work, if I believe I'm quoting you correctly. And like, yeah, that's a really cool goal, and the stuff that comes out of that could be totally crazy. I want to flip that on its head just a little bit and ask the ethics brain and the philosophy brain within you about like, what's the most threatening thing about that, and what's the thing that we shouldn't feel threatened by at all, even if it looks scary? Lots of hash has been made about like, oh no, Skynet, oh no, misinformation campaigns. But clearly, neither of those have happened just yet, unless someone in here is a Cyberdyne engineer. But you get the idea. What's something that we should be scared of that we don't know about, and what's something we shouldn't be scared about that we maybe know a little bit too much about?
I think, related to the last question too, one of the things that I think a lot of people are scared about, and probably maybe should be in the short term and medium term, but in the long term I think we'll figure out, is like all these economic questions, work, like it'll be fine. Like you're gonna adapt. Like that's what you're gonna do. It might suck. We talked about that before, right? Like those nights that I was doing my stuff on my own and I had to adapt. It was awful. It was not a pleasant experience. I wouldn't fear it, I guess, to your question in particular, because I think the version of us that's on the other side is better, according to some third objective that I guess is just my own internal sense. So it'll probably be hard at various points, especially the longer you wait. But if you're learning a lot and you're pursuing your own creative ideas and shaping yourself, then like you're gonna be fine. Something that you should worry about or fear that people don't fear enough.
Mine would be just the decohering of humans as a social being. We're suddenly
Yeah.
grasping farther and farther up the tree of like, what are we? What are we? Oh no, we don't know what we are because our mechanisms of determining that are falling apart. Like,
Yeah.
I don't know.
Yeah, I mean, I think that's like with social media, right? You see linguistic communities sometimes come together that have very different values and very different, I don't know, political ideologies, religious ideologies, or maybe not. Maybe just like slightly different linguistic communities that talk about things in slightly different ways, and it leads to all this like conflict in the talking realm, at least. And there's a version of AI that helps with that, and there's a version of AI that maybe reinforces it. Is it reinforces? I don't know. See, I think I'm talking myself into optimism again, because I think like I think that
I don't have to corner you into being a techno-optimist.
no,
Being not a
okay.
techno-optimist.
Here's something I'm actually worried about. I have a great appreciation for like a lot of different languages. So you can think about languages or perspectives or value systems, whatever they are. Like that diversity is, I think, really valuable from a philosophical standpoint because it helps you represent the universe and the world more completely. Like if you had one language, like only English, then there are words in other languages that describe feelings and experiences, different kinds of snow, in a way that like English cannot do. And so if really powerful unified models end up being essentially just propagating the power dynamics of the current distribution and flattens that into one, that doesn't seem better to me. It seems like we traded representational power of capturing human experience and sharing that for like informational efficiency. Like, imagine a world where we all just talked language and all the other languages died.
Yeah.
Like, on some level, that's good because it's way more efficient and you never have to translate, you don't have to do anything like that. We all get to talk to each other. No matter anywhere you go in the world, every sign, you understand it, et cetera, right? But it just kind of, I don't know, it feels bad to me. It feels like we lose something when you do that. And so I worry a little bit that even the thing that I believe in, which is like a unified model, I hope it captures everything instead of squashing everything down to like the most efficient things, which is a very real concern.
Yeah.
Because efficiency is kind of tied to the optimization process. And so, yeah.
That's a great thing that I hadn't thought of. Thank you.
Thank you for your question.
Hello. I think you've been subtly answering this question the entire time, but to put a finer point on it, you had a bachelor's in philosophy and then moved into a master's in computer science. I have a bachelor's in computer science and I'm getting a master's in linguistics.
Nice.
People don't always understand that inclination. So how do you assert that it is not only an important part of who you are, but an important part of your success?
Well, important part of who I am. I was not going to graduate without the philosophy degree. Like I just refused. In fact, the whole reason my master's took 2 years is because I used some loophole in the system to like finish my philosophy degree while I was doing my computer science master's. I was just like not gonna, because I did a computer science bachelor's as well.
Okay.
So I don't know, there's just like maybe the historical evidence of my action that like I felt like it was really important. But I think even when I was doing both as an undergrad, before I knew about AI and everything, I just think for me, linguistics or philosophy, a lot of the humanities, it can be like way more complementary to your thinking and like perspectives and approaches to the world. Like I don't think anyone at the time that we were talking about in 2013 that I talked to in the computer science department, even the people working on deep learning for natural language processing, were doing it for like the same reasons. And those reasons were the ones that like kept me motivated and, motivated teams to work with me. And there's still things that like I enjoy talking about with people a lot. So they were like fundamental to the whole project. Like the project doesn't even make sense in my head without the rest. If it was, I don't even know how I would have like guided myself or done any of it without it. So I would say computer science technical stuff is great. And you don't need something outside of that. But for me, I did. It was essential for who I am. Like operating systems were great, but I was in my operating systems class, like writing down metaphors between like threads and the versions of myself that were like running in my head and like flipped back and forth depending on the day.
Hume.
Yeah. So it's I just couldn't help it, I guess. That's not a good argument, but it's the data.
It is what it is. Thank you.
Awesome. Well, it sounds like we're going to have lunch now, but let's give Bryan just a round of applause for being here. Thank you. Thank you for choosing Joplin, Missouri to spend a couple days.
Yeah, it was awesome. I learned about a big fork, and I'm gonna go to the aquarium, and I heard there's a big gas station. So thank you
Awesome.
so much for having me. It was
Thank
great.
you.
Thanks for the organizers as well.